Welcome, I'm Professor Parker, sponsored by Dirt Bike Dads. So the purpose of our experiment is to determine the effect of the knife bevel on the force required to cut through wire. We expect the force required to break through the wire to range between 0.1 to 10 newtons. As you can see here, we have our shear stress versus our bevel angle graph, and we expect a small bevel angle to correlate to a small shear stress and a large bevel angle to correlate to a large shear stress in a linear fashion. Here's a diagram of our knife bevel right here with the associated angle, and then this is our wire that we'll be cutting through. We'll measure the force and the angle and calculate the shear stress, which has associated uncertainty, which we will determine through uncertainty propagation. After gathering our data, we use a chi-squared test to determine if our data is distributed in a Gaussian way. And then we'll do a student t-test to find the confidence interval for our data. Here are some of the sources of uncertainty that we expect and some of their values. So for the angle, we'll use a protractor to measure it, and we expect an uncertainty of about plus or minus 2 degrees. Next, for the scale we're using has an uncertainty of 0.01 grams. Lastly, the calipers. They have an uncertainty of plus or minus 0.001 inches, or because all of our measurements we want to be in the metric system, that's equivalent to 0.0254 millimeters. Here's how we plan to minimize the error of our experiment. So first, when we put the contraption on the scale, we're going to tare it so that we don't have the weight of the contraption affecting our measurements. Next, we're going to place the wire in constant tension using the brass weight. And then we're going to isolate the experiment from any high traffic areas or anything like that so that we reduce the noise of our measurements. And then lastly, we're going to put a ball bearing at the joint of the moment arm to reduce any friction caused from the joint.
For our setup, we'll first start by cutting the wire that we are using. Then we'll be putting a brass weight or any sort of weight to tension the wire once we are setting up on our prototype. After adding the tension to the wire, we will attach the wire to our prototype by wrapping it around the screws, as you can see in the video. And being attached to the prototype and setting the screws tight, we then let the weight free so it can tension the wire. We cut the wire.
Here we put tape onto the prototype to secure it to the scale. We tare the scale so that the weight of the prototype does not affect our readings. We record the weight of the scale until the wire breaks. Our PPE includes safety glasses and gloves. Some things that we want to improve for our next test run is we want to widen this gap so that the wire doesn't cut due to the edge, but instead cuts due to the bevel. We want to also make sure that the bevel is parallel when it's in contact with the wire, and we will do that by moving the blade up so that it's parallel.